In these examples, we're going to look at the relationship between the numbers of protons, neutrons, and electrons in an atom, and how they relate to things like atomic mass and the mass number. So on the bottom here, I've got some reminders of how these different subatomic particles are related. So for neutral atoms, the protons are always equal to the number of electrons. Now, if you're dealing with ions, I'd recommend looking at one of my other videos that is similar to this one, but for Chemistry 1151, you don't need to worry about the ions. Now, it is always true that the atomic number is equal to the number of protons, and you can get the atomic number from the periodic table. It's generally the number written above the atomic symbol. The mass number is the sum of the protons and the neutrons. Now, I have to remember, you cannot get the mass number from the periodic table. The number related to mass in the periodic table that's usually written below the atomic symbol is not the mass number. It's actually the average atomic mass, and so it accounts for different isotopes of that particular element. Whereas when we're asking for the mass number, we're talking about one specific isotope of that element. So again, the mass number is not on the periodic table. You cannot get the mass number from the periodic table. You have to get it from adding up the protons and the neutrons. All right. Now, sometimes when we write atomic symbols, we like to write the atomic number and the mass number in them. So if we write an atomic symbol including those, we write the mass number to the upper left of the atomic symbol, and if we write the atomic number to the lower left of the atomic symbol. All right, and then this chart is representative of how I often like to ask these questions. So I'll give you one or more entries in the chart, and then you have to fill the other ones out. All right, so if we do this one, so we may need to do the orders of the items in the table differently depending on what information we have, but in this case, I think we can kind of work our way across. So for the atomic symbol being N, I would look on the periodic table to find N, and to help me find that, I might even look for the atomic number 7. And I'm not going to pull up a periodic table in this video, but if you want, you can pause it and pull out your periodic table and then kind of follow along with me. So if you want, pause the video, see if you can find the element N in the periodic table. Okay, if you found it, then you know that N is nitrogen. All right, now the atomic number, we need to get that from the periodic table. The number above nitrogen is 7, or, right, we've written it in the atomic symbol, so we know that the atomic number is 7. The atomic number and the protons are always the same, so I can skip ahead and go ahead and put a 7 for the protons. And because we're dealing with neutral atoms in these examples, the protons are always equal to the number of electrons, so I can fill out all of those entries right away. Now, the mass number I cannot get from the periodic table, but I can get it from the atomic symbol, and that they've told me that it's 15. And if you look at the periodic table, you'd see that the number underneath the N is probably something like 14.01, right? And clearly that's different than 15. So this mass number has to come from some other source of information. We can't get it from the periodic table. In this case, I gave it to you in the atomic symbol. So the mass number is 15. And then finally, for the number of neutrons, we know that the mass number is the number of protons and neutrons. If I know that I have 7 protons, then I can use, this equation to do 15 minus the 7 protons will give me 8 neutrons. Okay, so another example, only they've given us different information. So remember, in these examples, we're always doing neutral atoms. So if I know there are 17 electrons, then I know there must also be 17 protons. And the atomic number is always equal to the number of protons, so I can immediately put a 17 down there. To get the mass number is the protons plus the neutrons, so I can add these two up. 20 plus 17 is 37. And then for the atomic symbol, right, I'll go to the periodic table, find atomic number 17. If you want, pause the video, look at your periodic table to find number 17. Okay, you should have found that atomic number 17 is chlorine. And then to finish off the atomic symbol, I'll put the mass number to the upper left and the atomic number to the lower left. And of course, this is chlorine. Okay, here's another example. So here we're told that the element name is strontium, so I can go to the periodic table and see if I can find strontium. So take a second to do that now. All right, if you found strontium, you see that he is Sr. His atomic number is 38. So I can put the 38 down there. I can put my 38 here. I know the proton's the same as the atomic number, so I can put a 38 here. This is a neutral atom, so the electrons also 38. All right, to finish things off, in this case they gave me the mass number, so I can put it on top there. And then to get the number of neutrons, I would do 90 as a mass number minus 38 for the protons. And so my number of neutrons is 52. Okay, so on this example, now they've given me the atomic number, so I can go find atomic number 20. Take a second and find that on your periodic table. Okay, 20 is calcium. Go ahead and put a Ca in here. I can put the atomic number down where it goes in the atomic symbol. If I have the atomic number, I have the protons. Because this is a neutral atom, the protons and electrons are the same. And then to get the mass number, in this case, I know that the mass number is the sum of the protons and the neutrons, so all I have to do is add 20 to 22, and I get a mass number of 42. I can put that where it belongs in the atomic symbol. All right, if you're doing examples with ions, if you're in a class besides Chem 1151, I've got 2 other videos on YouTube that do similar tables, but only involving ions.